So we're still continuing the discussion of the measures of associations in pharmacoepidemiology. And as I mentioned, we started with what are the measures of association when you're dealing with a cohort or RCT. And we talked about the relative risk, we talked about the odds ratio, we talked about the attributable risk, and we talked about the number needed to treat, focusing on the fact that you're dealing with either a cohort or an RCT. Yani, what you're seeing are incident cases. And we discussed everything based on that. Hala, in a design of a case control design, which we will have a lecture talking about that, but let me just give you a quick overview of things that you already know about case control design, the way it is built up. So you probably remember that in a case control, it is set up such that when you come to select your participants, you look at the outcome. So you check the outcome, whether it's a disease or it's hospitalization or side effects. You look for that and you find those that have it, and you get those that do not have it. These are called your cases, and these are called your controls. And therefore, you decide you may want, مثلا, 100 case and 100 control. So that number is set by you as a researcher. And after you do that, you start checking if they were exposed or not, if they had the exposure or not, in both. So نفس الشيء here and here. And what is important about that is, since you're looking for those that actually have the outcome and those that don't, so these are actually not incident outcome, but rather prevalent outcome. And now you know شو الفرق بين incidence و prevalence. So these are prevalent. You're يعني not only they have the outcome, but they also might have it for a long period of time. You're also missing those that had it and were healed, or had it and died. Um, so and also the last thing is that you're starting by the endpoint اللي هو outcome, and then you're going back into the exposure, and therefore it's called a retrospective design. Point being, this design does not allow you to calculate incidence. So we cannot calculate incidence, and therefore we cannot talk about risk. Okay, so we have to do something else. But so let's go back to the lecture. Okay. So this is the general setup of a case control design. You have the cases here, you have the controls, and you're going to divide your cases either exposed, not exposed, and the control exposed, not exposed. Mind you here, this time A plus C is determined by the study, and the B plus D is also determined by the study. Whereas in the RCT, ولا in a cohort, يبقى exposed, the total exposed and the total not exposed, who is determined by the study. من هيك بالRCT والcohort, I said you can only calculate inside the exposed and inside the not exposed. In this setup, since the study is that way, you're determining the total cases and you're determining the total controls, you might have guessed it, you're only allowed to look inside the cases and inside the controls. Okay? So you're only allowed to look inside the cases and inside the controls. You cannot calculate across, just هيك cases, controls. حتى total, it's not allowed for you to do that. Okay? So only calculations are only permitted within the cases or within the controls. So the proportion of exposed among cases or among controls can be calculated. It is not permitted to calculate the proportion among exposed or among non-exposed. Okay, ما فينا نطلع cross مثل ما كنا نعمل بالRCT. So proportion of cases in the exposed or proportion of cases in the not exposed is not doable, it's not allowable. You only look at the proportion of exposed among cases, inside the cases or inside the controls. So what are the things that you can calculate, and it's okay to calculate it? It's okay to calculate the proportion of the exposed, the cases among, let me say that again, exposed among the cases. So هول الcases وهول الcontrols, our example is myocardial infarction, and you have, I think this was obesity, so obese, non-obese. Okay, so عندنا cases of MI controls وعم نشوف قد ايه في عندنا obese. So 100 and 100 because I as a researcher sent out, looked for 100 cases of MI and 100 control, and then I'm checking their obesity level. So what is the okay things that you can calculate? So the first thing that is okay to calculate is the proportion of obese among cases. هيدي السلاش يعني among. Okay, among cases. So I can look at obese among the cases 40 على 100 أو the non-obese among cases يعني 60 over 100. That is okay to do. Same thing among controls. So I can look at the 15 over the 100 or the 85 over 100. That would be okay to do as well. That if you're doing proportions. But you can also do odds. Okay, remember the odds from previous lecture is the success over the failure. So you can calculate the odds of the obese to non-obese among the cases. أو العكس, the odds of the non-obese to obese among cases. Also, you can calculate the odds of obese to non-obese among controls. والعكس صحيح, as long as you're doing it among cases and among controls. So the odds that we're calculating here, very importantly, is the odds of the exposure to non-exposure among cases versus the odds of exposure to non-exposure among controls. I'm gonna do a quick review of what we used to do in the other designs لفرجيكم الفرق in terms of interpretation, because that is going to be very important, the way we interpret it. لأنه very soon you will discover that calculation wise you're going to get the exact same formula, whether it's a case control or it's an RCT or a cohort. You're going to get the exact same formula. However, the interpretation is very different. So let me explain that. So let me clean up here. And what I'm going to try to do is set up the two designs. So here we have the cohort design, our RCT, and here we have the case control design. Okay, and I hope I can do it nice. All right, so here's the setup. Here's also the setup. So on the outcome. So outcome and no outcome. بعمل بار يعني no outcome, وهون exposed and versus not exposed. Okay, نفس الشيء over here, outcome, no outcome يعني case control, and exposed and not exposed. Okay, what happened, maybe I can type in A, B, C, D, A, B, C, D. All right, so what we calculated in the cohort was the odds of the outcome to no outcome in the exposed. So we calculated the odds of the outcome among the exposed, and we also calculated the odds of the outcome among the not exposed. Okay, حطينا C على D. Okay, so هيدي كانت A over B وهيدي كانت C over D, and then we did the ratio to get the odds ratio, and our interpretation was the odds of the outcome for the exposed is that much of the odds of the outcome and the not exposed. Okay, now whereas on this side you're allowed to calculate the odds of the outcome to no outcome, sorry, exposed to non-exposed among the outcome, and the odds of the exposed to the non-exposed among the non-outcome. So هالمرة الodds هو of exposure among outcome and the odds of the exposed among the controls, يعني cases and controls. Okay, so that is going to be A over C, and this is going to be B over D. Okay, What's going to happen is, I told you before that if you rearrange, it's going to be the cross multiplication, and you're going to end up with AD على BC on. Strangely enough, if you also rearrange whole, you're going to also end up with AD على BC. So really the formula for the odds ratio is exactly the same, whether you're doing it in a cohort or you're doing it in a case control. مشان هيك عم أكد عليكم the interpretation has to be different. إذا عندكم cohort, you talk about the odds of the outcome. So the odds of heart disease among smokers is 3 times the odds of heart disease among non-smokers. بتكونوا عم تحكوا على cohort. أما إذا قلتوا the odds of smoking among cases of heart disease is 3 times the odds of smoking among those that do not have heart disease. بتكونوا عم تحكوا على case control. The interpretation, I hope by now, is very, very different. So نرجع to our slide. The things that are not okay to calculate anything, مثلا the probability of the outcome or the proportion of the whole. 55 على 100 it's not okay to calculate. 100 على 200 it's not okay. كل شيء من برا it's not okay to calculate. And this is also true for RCT and cohort. Calculating things from the outside are not okay. In RCT and cohort, within exposed, within not exposed, and for case control, within cases and within controls. So anything that is going across, مثلا among obese cases, among obese, صرنا عم نروح among obese صرنا هيك هول, that is not okay. Among not obese, that is not okay. The odds of case among obese is not okay. The odds of control among is not okay. Okay? Whole كلهم are not okay. You cannot calculate these. You can only look within cases. Sorry. And within controls. I know that probably now it's clear, but I like to أكد على الموضوع. So let me go back to this example. And therefore, the proportion of obese among cases, 40 over 100 is 0.4. The proportion of obese among control is 15 over 100, that's 0.15. The odds of obese among cases is 40 على 60, 0.67. The odds of obese among control is 15 على 85, 0.18. And what I did now is instead of taking 100 cases, 100 controls, قررت اخد 200 cases and 200 controls. And I did that on purpose because I want to show you that as long as I'm doing my calculation among cases and among controls, the values do not change. بعده عم يطلع عنا 0.4, 0.15, 0.67, 0.18, exactly what we had in the previous slide. Because I'm still doing my calculation inside cases and inside controls. Okay, I told you it's not okay to calculate across. So here I'm showing you the dark, the original sample size, the blue, the sample size after I've changed it. And what I'm doing here is I'm doing the things that are not okay to do, and I do that on purpose to show you how the values would change. So if you were to calculate the proportion of cases among obese, يعني 40 على 55, it will give you 0.73. However, when I change my sample size, it becomes 80 على 140, so it becomes 0.57. You see how it's changing? It's not supposed to be changing just because I changed my sample size. يعني لأني بس غيرت the sample size, I'm getting different value. That means you're calculating something that you're not supposed to calculate. And don't do that. So in conclusion, any calculation based on exposure or non-exposure will depend on the number of cases and controls selected, and therefore you should not do. You only are supposed to calculate things within the cases and within the controls. And it is clear that in case of a cohort design, since the sample is based on selecting the exposed and the non-exposed, or calculation should be done within the two groups. On two groups, I mean by that the exposed and non-exposed. Whereas in the case of a cross-sectional study, which I will talk about later on. A cross-sectional study, خليني أقول لكم what happens in cross-sectional study. So in a cohort, you're selecting your exposed, total, and non-exposed. أنتوا قررتوا على total here وhere. In a case control, أنتوا قررتوا على total here and here. What happened in a cross-sectional design, you're not fixing anything. So the table that looks like this, okay? So these are the that have the outcome, and these are those that do not have the outcome, the exposed and the not exposed. What happened in a cross-sectional is just you get a sample regardless, and then you start distributing it how you observed it. And therefore, in that scenario, in a cross-sectional design, you can calculate everything you want. You can calculate هون total, you can calculate هون anything you want, you can calculate. But make sure that you're not talking about risk كمان لأنه حيكونوا prevalent cases. You need to talk about prevalence. So in a case of the cross-sectional design, the sample is selected regardless of exposure and outcome, and thus any calculation is possible. You can calculate whatever you want in a cross-sectional design. Uh, that takes us back to what I just mentioned about the two types of odds ratios. في عندنا type that is calculated in case control design. This is the odds of exposed among the cases على odds of the exposed among the control. This is used in a case control. أما the odds of the disease in the exposed على disease in the not exposed, this is calculated in cohort or RCT. Also, it can be calculated in cross-sectional designs as well. All right. So the formula that I showed you previously, the odds of the exposed among cases is A على C. The odds of the exposed among the controls is B over D. And when you rearrange things, you go back to AD على BC, which I already told you that you're going to get the same formula. And that's the danger thing about odds ratio, is that you get the exact same formula regardless of the design that you're working with. منشان هيك it's dangerous for people to do the interpretation if they don't know what design they're using. This is a cross-sectional design or a cohort design. You can calculate the odds of the disease على exposure, the disease on non-exposure, and you get the exact same formula. You've seen this before. This is just to show you again that the formula is the same exact one. We come to how would you calculate the confidence interval for the odds ratio in a case control. Exact same thing we do in a cohort, the same exact formula. So you're going to calculate the natural log of the odds ratio. That would be your A. The C is the 1.96 times the 1 over A, 1 over B, 1 over C, 1 over D. This is, if you remember, your standard error. This is your test. That is going to be your C. مرة بتعملوا A minus C, مرة بتعملوا A plus C. You exponentiate to go back to the space of the odds ratio, because it can be natural log over here, and you've calculated your odds ratio and your confidence interval. So we go back to the example that I started with, the example of 100 cases, 100 controls. I'm looking at smokers, non-smokers. For the 100 cases of lung cancer, خلينا نقول 70 told you that they were smokers. أما بال100 controls 30 كانوا بس smokers. If I ask you to calculate the odds ratio, it's very simple. 70 times 70 divided by 30 times 30, and you get 5.4. The way you're going to interpret this 5.4, you're going to say the odds of smoking among lung cancer patients is 5 times bigger than the odds of smoking among controls. Okay? The wrong way to do the interpretation is to say the odds of lung cancer among smoker is 5 times than among non-smoker. This would be the odds ratio that we would be in a cohort. Although the calculation is exactly the same, but it would be wrong to interpret it this way. Here we interpreted the odds of smoking among lung cancer cases is 5.4 times greater than the odds of smoking among controls. As I mentioned here, a relative risk would be inappropriate to calculate. Next, I'm going to show you the confidence interval, which we did before. So you take the natural log of your odds ratio. So the natural log of 5.4 is 1.6864. The next thing you need to calculate C. C is 1.96 times the standard error. The standard error is 1 over 70, 1 over 30, 1 over 30, 1 over 70, and you square root all of this. So your standard error is 0.3086. That standard error is multiplied by the 1.96, you get the 0.6049. This is your C value. Next, you're going to take A and subtract the C from it. Also, you're going to take the A and add the C to it. And you're going to take the exponential of each of these values. So your lower limit for the odds ratio is 2.95. The upper limit is 9.85. Now for interpretation, this confidence interval of the odds ratio does not cross 1, and therefore the odds ratio we calculate is statistically significant. If you want to do more interpretation, you can say that the odds ratio of smoking among lung cancer to smoking among case controls could be in the real population as low as 2.5 to 2.95 and as high as 9.89. Okay. هلا and I've mentioned before previously that the odds ratio is not to be interpreted as a relative risk. In this scenario, we have two reasons not to do that, because the odds ratio formula is different than the odds ratio of a relative risk. Plus, you're dealing with the case control design. However, in a specific scenario, which is rare to happen, but in case your cases selected are incident cases only, and your controls selected are representative of the controls group, وما فيهن prevalent cases at all. Your cases are a good representative of all cases, and your controls are representative of all controls. يعني the selection that you did is a very good selection. In addition, in your cases ما عم تاخدوا prevalent cases, عم تاخدوا بس new cases. In that specific scenario, which is rare to happen, then the odds ratio will be very close to the relative risk, and you are allowed kind of to interpret your odds ratio as a relative risk. But this is something that is rare, and it doesn't happen very often. Okay. So here I would like to go back to the Excel sheet in the previous slide, where I was showing you what would happen if I change the sample size. So in this setup, I have a case control setup. These are my cases, these are my controls. You can tell because I have 500 cases, 500 controls. Typically the cases equal the controls. This is an indication that it's a case control, and the researcher قرر بده 500 case 500 controls, and therefore you can only calculate within the cases and within the controls. The next thing I'm doing is I'm calculating the odds ratio. It's very simple. 150 times 425 divided by 350 times 75, you get an odds ratio of 2.4. So if you want to interpret this odds ratio, you would say the odds of the exposed among cases is 2.4 higher than among the controls. Over here, you can see that I have the confidence interval. So it's a quick reminder. That's the Z value that is changing according to the level of the confidence. Here is the D value, which is based on the standard error, which is right over here, and the standard error multiplied by the test. So if you look at the D value, it's the formula. I'm taking the standard error and I'm multiplying it. And to be able to get to the confidence interval, you need to do A minus D, A plus D, which I already did. And here you have the confidence intervals for these different values. So 90% confidence interval, 95 and 99. Sure enough, as you're going from 90 to 95 to 95 to 99, what is supposed to happen to your confidence interval, it's supposed to grow wider and wider. And therefore, you start off with a confidence interval of 187 to 3.16. It grows to 178 to 3.32, and it goes even wider to 1.61 to 366. Okay, so you're gaining in confidence, but you're losing on precision. The alpha is 10%, 5%, 1%. All of them do not cross 1. معناتها all of them are statistically significant. معناتها the p-value is definitely less than 10%, less than 5%, and actually it's less than 1%. And I can also double check that by doing the chi-square and getting the p-value. The p-value for this chi-square is very, very, very small, which validates what I was predicting. I was predicting a p-value less than 1%, and actually it is less than 1%. So next thing I'm going to do is, let me unhide what I had here, is I'm going to make my sample much smaller. So بدل ما اخد 500 ب 500 for a total of 1000, I'm going to just take 100 and 100 for a total of 200. However, everything else remains proportionately the same, and therefore your odds ratio remains the same. But what's going to happen when you reduce your sample size, your standard error becomes bigger, much bigger. Notice كيف standard error كان 1.58 هلا صارت 0.355, much larger standard error. And therefore, if you compare your confidence interval here to your confidence interval there, for the same percentage, this one is going to be wider because it has a smaller sample size. So a 90% confidence interval used to be 187 to 316. Now it's 135 to 4.37. You can see how much wider it is, much, much wider. The 95% confidence interval used to be 178 to 3.32. And now it's 121 to 4.87. And the last one used to be 161 to 3.66. Now it is 0.97 to 6.06. And the other thing you will notice that now the last one crosses 1, yani your p-value is actually greater than 1%. It's less than 5%, but it's greater than 1%. So based on this confidence interval, I can make the prediction that my p-value is going to be between 5% and 1%. I can actually do that by doing the chi-square and getting a p-value, and I got a p-value of 1.1%, exactly equal to my prediction. I was predicting a p-value between 1 and 5%, which is exactly true to what I have over here. So let's go back to our lecture. Next, I have example of odds ratios from the literature. So the example is a multi-center case control study for non-steroidal anti-inflammatory drugs as a risk factor for severe sepsis and septic shock. I'm not sure about the risk factor. The word risk here does not fit in the design, but anyway, let's look at how they did it. We conducted a multi-center case control study in 8 intensive care unit cases. So they looked for cases and they looked for controls. Cases were all adult patients admitted for severe sepsis or septic shock due to bacterial community acquired infection. So هول هن الكيسز. فتشوا على كل اللي عندهم septic shock or severe sepsis. Controls هن اللي ما عندهم هالشي. Controls individual or patient hospitalized with a mild community acquired infection. Each case was matched to one control for age, presence of diabetes, and site of infection. هلا matching وما matching, we'll talk about that once we get into the designs. Okay, so basically what matters for us that this is a case control design. الcases هن اللي عندهم septic shocks or severe sepsis. الcontrols ما عندهم. هلا بدنا نشوف شو exposure. Probably the exposure is anti-inflammatory drugs, non-steroidal anti-inflammatory drugs. So if you look at the results, you can read over here that they calculated an odds ratio and it came out to be 0.93 with a confidence interval of 0.52 to 1.64. So the first thing for us is that this confidence interval does not actually crosses 1, so it's not statistically significant. However, if we were to interpret this confidence interval 0.93, يعني the odds of being exposed to non-steroidal anti-inflammatory among the cases is 7% lower than among the controls. That's how we would interpret this odds ratio. Okay, and I think over here we have the table. So typically when you have a case control design, you're going to see the cases listed in one, the controls, and then you're going to see the exposures. And over here you have all the odds ratios with the confidence intervals and the p-values. And since they're calculating a 95% confidence interval, every time your p-value is less than 5%, the odds ratio are across 1. So 0.79 obviously is greater than 5%. The odds ratio confidence interval crosses 1. Same thing here. It crosses 1, crosses 1, crosses 1. The only time that we're going to run into trouble is over here. Here you have a p-value of 0.04, which is less than 5%. Your confidence interval are not cross 1. However, معهم طالع, it's crossing 1, and that probably because of some sort of correction to the formula that they're using. But أنا, for me, if I was doing this, what I expect from you is that if you see a p-value less than 5%, the confidence interval should not cross 1. Yani the confidence interval of this odds of 0.36, مثلا, it should go from 0.1 to 0.98, for example, okay? All right. So next, the odds ratio and the confidence interval. We already did this. We're going to finish up with the cross-sectional study design, which I'm not going to take a lot of time on it because it's actually the simplest design. You are selecting, regardless of the exposure and the outcome, you take a sample. بعد ما تاخدوا sample, you look at the exposure and the outcome. In that design, you are allowed to calculate anything you want. So you can calculate from the outside. يلي كنت عم لكم من شوي, you're not supposed to do that. So let's just me remind you very quick. Both in cohort أو RCT or case control, كنت عم لكم when you're doing the table, okay, كنت عم لكم you're not allowed to do any calculation from the outside. يعني you're not allowed to take this over the total, or this over the total, or that over the total, or that over. However, in a cross-sectional design, you can do calculation from the outside, calculation from the inside. You can do any type of calculations. The only thing that you should watch out for is that what you calculate, the same formula for a relative risk, don't call it a risk, call it prevalence. So we calculate exactly something like a relative risk. However, we do not call it risk لأنه منهم incident cases. We call them prevalence, and therefore we call it the prevalence rate ratio. Confidence interval, everything is exactly the same. Everything is exactly the same. هلا odds ratio interpretation, you can interpret it the exact same way you did it for the cohort. If you do in the cohort one, وحتى you can do the case control one. Confidence interval نفس الشيء, sample size related to standard error, everything is the same. The only thing is, if you were to calculate a relative risk, do not call it a relative risk, call it a prevalence rate ratio and interpret it as a prevalent rate ratio. يعني إذا طلع معكم مثلا the prevalent rate ratio equals to 2, you say that the prevalence of the exposed among, no, the prevalence of the outcome in the exposed is 2 times the prevalence of the outcome in the not exposed. Okay? So that's it for cross-sectional design. Very simple, straightforward. Survival analysis. This is basically something that more and more is done. And the idea behind it is, خصوصا for cancer, what happens is, again, you're back to having two groups, treated مثلا and non-treated. So these are the treated and these are the non-treated. And you know that by the time you've done the follow-up, everybody is going to be dead. So 100% dead in the first one and 100% dead in the second one. But you're interested in how fast they're dying. Eh? So you do a survival, and basically you do a curve that looks like this. So that's the survival. You start up with everybody being alive. So your survival is 100% at the beginning. And it started dropping till it reaches مثلا 0. So if this is for those that are not treated, you would hope the treated would have something that looks like this. Okay? So maybe at the end everybody is dead, but however, at any point in time, the treated have a higher survival than the non-treated. Okay? So this is called a survival curve, where you start up with everybody being alive at the beginning and you follow up till they died. This is for overall survival. It can be done for relapse, يعني اللي بيجي the disease, and for a number of things that I think you cover in the oncology rotation. However, what I want to say is that you can calculate something called hazard ratio for survival analysis. A hazard ratio is interpreted like exactly like a risk. يعني بدل مثل ما كنا عم نقول the risk is 2 times in the exposed versus non-exposed, حتقولوا the hazard of death in the exposed مثلا is 20% less than in the non-treated, for example. Okay, so it's interpreted very very similarly to the relative risk. بس بنقول hazard بدل ما نقول risk. You can also get a confidence interval, and you can also get a p-value. Um, كل الconcept that were covered for relative risk apply for the hazard ratio. هلا if you have more interest, we can look, you can bring articles and we can look at that, and we can spend some time on that, or you can review your PHA 421 lecture. We had few slides about the hazard ratio over there. That concludes the measures of association section for pharmacoepidemiology. I will have an assignment for you to do, and I will discuss that in class.